This seventh reading session organized by Kharagpur Data Analytics Group, known as KDAG. So today we have this paper titled Guide Me, Interacting with Deep Networks. This paper was accepted at CVPR 2018. Today we have two presenters. Myself, Sivasmanak Paigrahi. I am a third year undergraduate student of the Department of Computer Science and Engineering. I am a head at KDAG. Along with me will be, as usual, Sohan Patnaik. He is a sophomore from the Department of Mechanical Engineering and he is a student member at KDAG. So before going into the important nitty-gritty details, let's look at some very briefly at the important notes. So we realized that you all would be having some queries during the presentation. You might have doubts but if you have gone through the paper. If not, that's also fine. So please feel free to unmute and speak. But it is highly preferable that you put the questions in the chat of this meeting so that we can address them one by one at the end. And at the end, if our Google form link will be released just as a feedback, but we will also ask you to put any AI related paper to be presented in the next few sessions, but that is completely optional. It would be fine if you don't put it. Now, this slide deck will be available in this GitHub repository. The link is provided there. And please join the Slack workspace if you have not. And also subscribe to the KDAG YouTube channel. There is also a link to the talk on good AI blogs, resources, and topics. Please check them out if you feel free and have time. Okay, let's go to the main agenda. So first of all, we will introduce the paper, what it is all about. Then we will go to the architecture overview. Then we will go to the methods that they have proposed, which will basically be three things. One will be the guiding block. Next will be guiding by backpropagation. Then will be guiding with text. How these are exactly happening, we will see, not worry. Then we will straight dive into results, how the performance is changing with the number of questions being asked by the model, how the location of guiding block is affecting it, how the complexity of hints provided, guiding multiple times. We'll be covering all of them. We'll straight go to the conclusion and that will end the session for today. Now, Sohan will be starting from this.
Okay, so before going into the actual content that this paper has proposed, let's have a complete picture what's going on. In the first column, you can see one input image, and you can guess that this is a semantic segmentation task, where we are just segregating different classes. You can observe that the ground truth has two classes, that is the sky and the playing field. But suppose we have one CNN, and we are getting some prediction, that is the original prediction, that is the third row, where you can see that the ground or the playing field is brown colored. Like the CNN is not able to recognize the field properly. The authors in this paper, what they did, they proposed an idea that they will give a hint to the CNN network, and that network will then alter the prediction and correctly segment the field. So that is the refined prediction that you can see in the photo. So basically the idea is that we are going to give some hint to the network. It is going to alter the predictions and we are going to get a better prediction. You can see other pictures and go to the research paper for more examples. Okay, so basically this paper outlines the idea of human interaction with deep learning models so as to improve the performance. A method was proposed that we are going to guide the pre-trained convolutional network through user input. Like this has been implemented in the field of image segmentation, as you can see in the previous image. And for example, this can be used in medical image analysis and computer assisted analysis. For example, suppose you take one image that is of a bone, an X-ray image of a bone, and it contains one fracture. Suppose that is present in the center of the image. Now, the network is unable to recognize that fracture. So what the doctor will do, the doctor will say that there is a fracture in the center bone present in the image. And this hint will in turn be used by the network to refine or to alter its predictions. So the core idea is to develop a guiding mechanism that will translate the user feedback into some changes in the internal activations that will then be used to change the output predictions of the network. Basically, the overview of the architecture is that generally what we have a CNN network that will get one input image and it will give some output mapping or output prediction. So suppose consider the image to be X. We divide the CNN network into two parts, that is the head and the tail. So basically consider the head part to be a function H and tail part to be a function T. So when we give the input image X into the head, it will provide one mapping that is H of X. then that h of x is provided to the tail, and the final output will be t of h of x. That is y tilde written in the bottom line. Okay, so now what the authors did, they introduced a guide in between the CNN head and CNN tail. So basically, we provide h of x to the guide. The guide will change the h of x, that is the activation of the CNN head, and then the altered activation is then fed into the tail to give some altered prediction. That is the basic idea about the architecture.
Okay, so that was a wonderful introduction to what the paper is all about. Now let us see what the methods they are proposing. So first of all, they are fixing the CNN. That is one important part. That is the head part and the tail part. They are going to remain the same. We are not going to do any kind of handling with them or playing with them. What we are going to do, we are going to introduce this guiding block, which the guide will use to modify the output of head and then pass it to tail. Cool. Now, how that guide block will be or guiding block will be designed, that is with the help of two guiding procedures. One is with the help of back propagation, another one is with the help of natural language input. We will see one by one. Now, first of all, the network encodes specific feature in each channel. So, if I give you a picture and let's say after the head can be a r to the power h cross w cross c dimensional vector, a matrix or tensor, and let's say I will denote it by a. Then this a can be represented as having c channels. And then let's say I'm taking a car example, then here it can be a car's wheel, here it can be car's door, here it can be car's window or something kind of that. So this contains specific feature across the channel. Now the guide's idea is basically to strengthen or weaken each activation available across the channel. So how it can do that? It can either emphasize the information or the activation, or it can suppress the information activation in a particular channel. How can it do that? Okay, let us see. Now, what is AC? Let's say C is a particular channel, then AC is the feature map for that channel. Okay. Now, let me introduce two numbers, let's say gamma CS and gamma CB, which will alter the information content in that particular channel. So let us see one thing, like let me do the bias to be 0, and if I put gamma CS to be 1, then the output AC dash will be twice AC, which means that I'm doubling the information content or doubling the activation present in that particular channel. Cool. Now if I do gamma CS to be 0, then it is becoming only AC. What is AC basically? AC is going to be the same information content. I am not touching it at all. I am just passing the same information. If it is becoming -1, then it is becoming 0. What does 0 here mean? 0 means that I'm completely suppressing the information present in that channel, which means I'm simply throwing out the information in that channel. I don't care about it. So this is semantically manipulating the information, because these are across the channel we are encoding the semantic information in the CNN. Now this seems very fair and easy, straightforward, but just imagine. Let me provide you some hint. Let's say the hint is on the top left you missed something. Let's say on the top left you missed the ITKGP. Then what can happen basically? This is the information in the spatial content. Like the information is something kind of that on the top left, like here. So this is across the dimension h cross w. This is not content. This information is not going to be content across the channel C. So I have to introduce something to manipulate the activation across this h dimension, across this w dimension. For that, I am defining two things. One is alpha h, one is beta w, and these were already earlier. So if I have a pixel AHWC, if you remember, A is the output of the head HX, then with the help of this equation, I am modifying the information content in that particular pixel. So this is all the guide is doing. So the head is providing the activation map entirely, and the information content across each of the channel. The guide is basically manipulating that value with the help of this alpha, beta, gamma parameter. That's all the idea about guiding. Okay. Now if you in the free time just sit forward and just think about it, these are basically tiling function which will arrange them properly, and this is Hadamard product, which is just element wise multiplication to do the multiplication calculation very fair and straightforward. Now easy. So y star is basically the new prediction. Okay. If you remember y tilde 2-3 slides back, we saw that it was the previous prediction. Previous prediction means when the guide was notified. And what is y? Y is the ground truth value. So please remember this notation. Y star is new prediction, y tilde is the previous prediction, and y is the ground truth. Now let us see the two important part, how the guiding is happening. First we saw what guiding is exactly. It is changing the information, and now let us see how guiding is being done. The first part is guiding by backpropagation. Now one thing is important, network revises its prediction without any additional learning. Why is this so? Just I said before. Like we are using or learning this alpha, beta, gamma parameter. We are not at all touching the filter parameters in the CNN. The head and the tail, they are completely fixed CNN architecture. We are not going to play with them. So we are just learning this alpha, beta, gamma. The guide is using them to modify the value of the head. So this is because there is no additional learning problem. Now, for a given x, a lot of jargons are written here. Forget about that. Let's see a picture. So let me say that this is a picture 4 by 4, and this is the output of the model, the tails output, like y tilde. So the model says this is a sky. Let's say this is a sky. This is sky, sky. Let's say this is dog. This is dog, and yeah, this is the output y tilde. Okay. Now, what is mask m cap and hint y cap? Now, the mask m cap is, let's say the model is saying, give me the output for this pixel, give me the prediction or the class for this pixel. Then the user will provide, let's say this pixel is, let's say sky. So the user will say the pixel that you have queried for me, let's say 1 2 3 4 5 6. So pixel 6 is sky. So what will happen to the mask? The mask is going to be a binary 1 0 matrix, which will be like this, very sparse, and its mask is basically showing where exactly the hint is being provided. Okay, so I'm providing hint at this pixel. And what is y cap? Let's say I denote the sky class to be 5, class number 5. Then I will say 0000 0500 and 0000 0000. So this is a very sparse input, and this is going to be y cap, m cap. These are to be defined. These are defined as I defined now. Then, if you imagine, y cap is same as y tilde and y's dimensions, because they are basically the pixel wise value for each category. Like this pixel which category, this pixel which category, this pixel which category. That is the dimension of y and dimension of y tilde. This is y cap, m cap. Now, what we were doing earlier, we were doing minimizing this loss, y tilde, comma y. Earlier, we were minimizing this loss. This is basically per pixel cross entropy for segmentation. Now, what we are doing, we are going to replace this by y star, because y star is the new prediction. But you remember one thing, y star is only due to the help of m cap. Like without m cap, it would not happen. Fine. So we have to do a element-wise multiplication with m cap. This means that I am just evaluating the loss for the hint that is being provided, and I do not give a damn about what is happening in the other locations. So this is my basic minimization task. Minimize this loss, and we will get the tuned alpha star, beta star, gamma star. Why? Because this y star is manipulated by alpha, beta, and gamma. This is all about guiding by backpropagation. But before going to the next part, guiding by text, there is a very few important things that we would like to say. One is how the query can be done, and the second is, it is better if the gradient descent falls to the local optima for this minimization task. Why is that? Because I'm just locally minimizing. I'm giving a local hint that this is going to be manipulated here, this is going to be this class, this pixel is class C. Then my aim and the model's aim should also be to be falling into a local optima, because we are just predicting closer to the hint, because I do not care what is happening in the rest of the cell because of the m cap or the hint that I'm providing. Now the second thing is, I said the model will ask what is pixel 6. Now why is pixel 6? Is there something special about pixel 6? Let us see once again. So what will happen basically, this is the output y tilde. Now for each of the pixel, let's say the model is predicting top 3 classes. Top one is, let's say for this pixel 6 is 40, second is 39, and probability I'm saying, and third is something else, we don't know. Then, and for this pixel, it is top one is, let's say 90, and second is 5. Then you see there is a stark difference between this, while there is a very small difference between this. So the model is quite confident what is happening here, but the model is slightly confused what is happening here. So what will model do? Model has the ability to ask to the user. So the model will ask, hey user, what is happening in the pixel 6? Give me the information, I will learn from that. That's how the model is asked at this point. Now this is basically 20 question game. So the model will say, give me the values for n1 till n20, and the user will say, okay, n1 is category C1, n2 is category C2, till n20 is class C20. So this is all about the guiding by backpropagation. I know that we are giving a lot of information. Please go through the paper after this session. That will be completely clear, or even go through this slide. It will be completely clear. Now Sohan will explain the guiding by text part.
Okay, so that was about how we can find alpha, beta, and gamma using backpropagation. Like we can interact with the network by using language only, or we can write something, and that is the way we humans interact with something. So in order to catch the hint that we provide into the network using language, we can use NLP or natural language processing to encode these like text into some hint. So how this was done? The input query was encoded into a word embedding matrix, and these embedded words are then fed into GRU, that is gate and recurrent unit. Now we have hidden states of GRU. Let the final hidden state be out. So how alpha, beta, gamma were predicted? Alpha, beta, gamma were nothing but some linear mapping of the output. That is, say the linear mapping is f, so alpha will be f of out, beta will be f of out, and gamma will be f of out. Now, the prediction of fixed CNN and ground truth were fed into the hint generator. Okay, what is hint generator? Exactly, we will know it in the next slide. Okay, so let me give you some information about the loss. Like the standard loss function that has been used is cross entropy loss, because we are dealing with classes here, like sky, dog, grass, all these are classes. So we are using the standard cross entropy loss, and observe that we are reweighting the loss by giving some positive weights to the classes that are mentioned in the query. Like here the class mentioned is sky. So if we give more weight to sky, then if the model predicts wrongly, if the model is unable to predict sky in a correct way, then the loss will be penalized more, as more weight is given to that particular class. So this ensures that if a wrong prediction is done, then more penalization is done and the loss function is high. So the model will try to minimize the loss function as early as possible. So this is the generating query part, where we are going to generate a query that will be fed as hint into the network. So for generating queries, a combination of functionality, semantic categories, and spatial layouts were used. What exactly is functionality? In the last line, you can see two words written in bold, that is RMV and find. RMV is nothing but remove, and find is nothing but find. So these are basically two queries. That find is something that you will tell to the network, find this thing in that model. Like there is a person in the top right. There is a person is the find query, and in the top right, here is the spatial position or spatial layout that we are specifying. So how this was generated? Suppose the output is, consider the image figure 2. So the output prediction of the head is divided into an n cross n grid, and for each grid cell, the erroneous classes were searched. So after the erroneous classes were searched, the classes were randomly sampled and a class was picked from that, and then using that, suppose we pick the class person, so, and the model is unable to predict that person class properly. So we will feed into the network that there is a person, and we will specify in which position that person is missing. So you can see that there is a person in the top right will be the find query. Consider the last point, that is, it was observed that remove yielded lower performance gain than find. So why this is so? Okay, in find query, we are specifying to the network that you are performing this particular thing wrongly. But in remove query, you are just telling that you remove this thing from the picture. You are not specifying what it should replace it with. Like what, suppose you say that remove the person in the image, then you are not specifying it what it should replace. So that is the reason why this yielded lower performance gain for remove query than that of find.
Okay, so that was about we saw what the guiding block is, how we can guide with the help of backpropagation, and the third one was how we can guide with the help of textual information or the textual hint. Now let us see what happens. If you remember, we saw a 20 question game in the guiding with the help of backpropagation. So this result I will provided here with for the top 20 means the 20 question. So the model can ask 0 question, model can ask 1 question, model can ask 5 question, 10 question, 15 question, and 20 question. So this how with each asking, like with each information on pixel, the model is enhancing its performance because simply it is being provided with the hint. So let's say I'm asking 10 queries, then I'm getting hints for 10 particular pixel. If I'm asking 20 queries, I'm getting information for 20 pixel. So like that's the basic information. That's the basic reason why the performance is improving.
Okay, these results are based on the location of the guiding block. Where exactly are we going to place the guiding block, and how the results are going to change. So as we observed that the CNN block is split into two blocks, that is the head and the tail. So we are going to put the guiding block in between them. So if we put the guiding block in the early layers, then high level information has not been captured in the output of the head, right? Only the pixel is like, yeah, basically high level information is captured in the later stages of the layers. So intuitively we can say if we place the guiding block in the later layers, then more high level information will be captured there, and we are going to give a better hint to the network so that it can manipulate the output predictions. And as you can see that the results mean intersection over union, that if we place the guiding block after fifth layer, that is res 5c, the mean IOU is maximum. And the intuition is that high level information has been captured in the later layers. Okay, consider the table on the left. As we have mentioned that they use two types of queries, that is the remove query and the find query. Using only remove query yielded not so good performance, and the intuition is that we are not specifying anything by giving a remove query, and if we explicitly use find query, the result is the best as observed by the authors. Now consider the table on the right. This is based on the number of hints that is given to the network. So as the number of hints increases from 2, you can see that the network is going to overfit. Like we are giving almost all the hints that are possible the network to get. Like suppose the network has 3 classes, and for we have already given it about 2 classes, like the sky is present and the person is present, and again we are going to give some hint about the third class, then the network is going to overfit and it is not going to learn anything on its own. So basically when we provided hints, it increased till 2 hints and then it started falling down.
Okay, so that was all about results, how various factors, various parameters affected. But before going to the conclusion, like this is the last slide, so we will really refer you to read the original paper. It's very small paper, it's not at all big. And second thing is it's written very simple language, and just you can read in one setting. It's like very straightforward and very simple to read, and it's actually very exciting. Also, we have missed 2 parts here because of time constraint. One is the failure cases where the model is failing actually, or this approach is failing. And the second is, if you remember the gamma vectors like alpha, beta, gamma were defined. Those gamma vector can be defined for each of the category. Let's say there are 30 categories. For each of the category, you can define them. Then how exactly their semantic information is being captured in the gamma vector. That is also represented there in the form of a TSNE map. Now, this paper proposed a novel method where human intervention with the network helped improve the performance just because the humans are able to provide the exact information that a network wants. Network is asking, okay, hey Sohan, give me the idea for the pixel number 2. Then Sohan will give that, okay, pixel 2 contains a star. That's like direct answer to what you are asking. And the next thing is this idea has a future perspective also, where the author suggests to design a more complex network to generate more complex queries, which can play the role of a proper user. Here there are certain standard templates which they're using, but they're trying to generate more complex queries. So that's all about this paper. Thank you and have a very nice evening.